The initial encounter with this weapon evoked mixed reactions. Its steel construction, which appeared to be assembled from disparate elements, was regarded by some observers more as a technical curiosity than an effective combat tool. The initial introduction of the weapon to military personnel sparked skeptical assessments regarding its operational characteristics. However, after several weeks following the first shot, which produced a significant acoustic effect and shook the ground, the initial reactions gave way to an acknowledgement of its power. This marked the beginning of the Obice 305-17 Howitzer's history, model of 1915, characterized by an unusual appearance combined with high effectiveness. In the early 20th century, the Italian Army received howitzers manufactured by the Armstrong company from the British side. According to specifications, they boasted significant characteristics: great mass, accuracy, and long range. However, in operation, these systems proved cumbersome, had a slow readiness for firing, and were high maintenance, which reduced their effectiveness. Italian artillery personnel expressed dissatisfaction, and engineers encountered difficulties, while the British side likely did not attach sufficient importance to these problems. However, the Inspector General of Italian Artillery held a different opinion. In December 1906, he outlined new requirements: the need for a howitzer capable of effectively destroying fortifications and concrete structures, while eliminating reliance on external developers. By the end of 1908, the Italian government announced an international tender. Leading European arms manufacturers, including Krupp, Schneider, Saint-Chamond, and Armstrong, participated in it. The Armstrong Company entered into an alliance with the Neapolitan firm Pozzuoli to participate in the project. This marked the beginning of the weapon's development. As a result of several years of design and development work and testing, a howitzer of 305 mm caliber with a barrel length of 17 calibers was created. Its mass was such that considerable effort was required for its relocation, comparable to the work of a technical personnel unit. The weapon possessed significant firepower, causing ground vibrations upon firing. Its design, which included a complex recoil system, hydraulic cylinders, and a pneumatic recuperator, represented an advanced technological solution for its period. However, preparation for each shot was also notable. Each salvo required between 12 and 15 minutes, with the duration increasing as the crew fatigued. The sound of the shot carried for many miles. Shells weighing up to 400 kilograms were launched over a considerable distance, and within seconds caused extensive destruction in the impact zone. Even by First World War standards, this represented substantial firepower. Nevertheless, high firepower was accompanied by significant logistical and setup difficulties. Setting up the weapon in position required preparing a pit, mounting a platform, securing the carriage, and assembling the barrel. This process took up to a day of continuous work and required the use of a crane, a large number of laborers, and considerable effort. Among artillery crews, there was an expression regarding the laboriousness of deploying the weapon, indicating its lengthy and complex nature. However, once set up and made ready for combat, the weapon demonstrated effectiveness against fortified targets, including bunkers and protected structures. Military personnel, accustomed to more compact field guns, noted the impressive appearance of this emplacement. Its tall structure, with a narrow track width, resembled elements of road machinery and armored vehicles of that period. Upon firing, the emplacement stabilized due to subsidence, and a bright column of flame erupted from the barrel, presumably emphasizing its destructive potential. By spring of 1915, the first units of this howitzer were adopted by the Italian Army. They were deployed in fortified positions along the coast and in the alpine regions. In mountainous terrain, characterized by snow, wind, and rocky slopes, the gun demonstrated its effectiveness. Shots created a powerful acoustic effect in the mountains, and their presence apparently impacted enemy actions. The introduction of this weapon into service was reportedly met with satisfaction in Italian military circles. It was asserted that this system provided Italy with unparalleled firepower in Europe at that time. The subsequent operational history of this weapon included participation in the battles of the Isonzo, intensive work by artillery crews, and the implementation of engineering improvements. In particular, Antonio De Stefano is associated with modifications that significantly increase the mobility of this stationary system, transforming it into a more versatile frontline asset. The arrival of the first batteries of this gun in mountainous areas revealed difficulties in its operation. Each shot required meticulous preparation, and the setup of each unit involved significant labor. In alpine conditions, operating the equipment was a complex task. Positioning at considerable altitudes where the air is thin required ammunition to be transported along challenging routes. The setup process involved site preparation, excavation for the support platform, mounting of the massive carriage, and lifting of the multi-ton barrel. On medium-density soils, these tasks took no less than 15 hours, sometimes up to 24 hours. During the daytime, cranes could be used, while at night, manual winches and torch illumination were employed. The work was accompanied by significant noise from tools. By dawn, the assembled installation stood tall at the positions, its appearance described as cumbersome. Despite the labor-intensive process, it was assessed that the achieved result justified the effort expended. As the gun was readied for combat, with the crew taking positions by the trails and the air filling with a hum, a general calm descended. The shot was accompanied by a shock wave that caused nearby individuals to press themselves to the ground. After the shot, a cloud of pulverized rock and concrete rose on the horizon. Despite its high effectiveness, the gun's design was considered cumbersome. Moving it between positions presented significant difficulties. Disassembling the gun required detaching the barrel, recoil system, and cradle, after which each part was transported separately. In some cases, transporting a single gun involved up to 8 trucks, an auxiliary vehicle, and several artillery tractors. Operation of the gun was accompanied by noted difficulties, yet its value in specific combat conditions persisted. In the context of positional warfare, where every elevated position and fortified strongpoint held significant strategic importance, this weapon had a decisive impact on the outcome of local engagements. It was used to destroy permanent firing positions, walls, and bridges situated in terrain folds. In areas where standard artillery was ineffective, this gun ensured the accomplishment of assigned objectives. Over time, and with changes in the nature of combat operations, a need arose for artillery systems combining high firepower with increased mobility. Command initiated requirements for increased maneuverability, which spurred engineering developments aimed at reducing the gun's mass. An updated version was introduced in 1916. Its design was simplified by removing certain components and optimizing the assembly process. This reduced deployment time. Installation time decreased from approximately 24 hours to 15 hours, with 6 hours allocated for earthworks. Despite this reduction, further improvements remained desirable. Despite the developers positioning the update as a mobile version, the system still featured significant mass and labor-intensive deployment. Transport in a disassembled state was possible, but infrequent. Each new relocation involved substantial strain on the equipment, personnel, and infrastructure. Regardless of classification, functional characteristics of the weapon were prioritized at the front. In areas with fortified stone enemy positions, this weapon played a crucial role in the outcome of combat operations. It was used to destroy stone fortifications, turning concrete into fragments. In the conditions of alpine passes, the sound of gunshots was greatly amplified by echoes, creating the impression of multiple artillery salvos. By 1917, the overall situation on the fronts had changed. A trend towards a protracted conflict was noted, which necessitated new technical solutions. The weapon retained its effectiveness, but its operation demanded significant resources. Among artillerymen, the possibility of increasing the system's mobility without reducing its firepower was discussed, as the weapon's disassembly process could take time exceeding the speed of the front line's displacement. The answer to this question was being developed by engineering specialists. One specialist, Antonio De Stefano, was already working on drawings for a new carriage, a system designed to solve a key problem. The necessity of a radical redesign of the existing mechanism was recognized to transform the heavy howitzer from a stationary installation into a mobile combat asset. Antonio De Stefano's name was well known in artillery circles. His experience included many years of service in artillery units, as well as deep knowledge of metals, mechanisms, and the principles of equipment operation. When he embarked on the task of ensuring the mobility of the heavy weapon, this undertaking was considered extremely complex by many. However, De Stefano continued his work, based on the understanding that the Army required not only a powerful instrument, but also a versatile means capable of rapid deployment to combat zones. Work progressed intensively. The existing design served as the basis, but its lower part, the carriage, underwent a complete redesign. The key concept was to eliminate the need for regular disassembly of the weapon and preparation of a pit for the installation platform. The new carriage was designed to ensure stability during firing while simultaneously allowing the entire assembly to be transported without dismantling. The task was complex, as the howitzer itself weighed over 12 tons, and the total weight of the assembly with its platform and equipment reached 33 tons. The proposed solution was distinguished by its originality and effectiveness in implementation. De Stefano suggested using a tall but narrow wheel design. Compensation for the center of gravity was achieved through a recoil system that guided the carriage along slightly inclined rails, utilizing the force of recoil. After firing, the gun recoiled, after which it automatically returned to its original position under the force of gravity. The mechanism functioned without the use of hydraulic systems or superfluous components, which ensured simplicity and high functionality. This mechanism allowed for firing without extensive preparation of the firing position. The rails could be installed directly on the ground, with horizontal aiming accomplished by means of a rotating base connected to the front part of the rail platform. For its time, this was a significant technical achievement. Tests demonstrated that, despite its overall bulkiness, the system functioned with specified accuracy and reliability. However, the design solution had certain peculiarities. The new carriage was notably high, nearly 3 meters, and narrow, which led to increased instability on uneven terrain. During transportation, the high center of gravity caused significant swaying, which led to the development of special metal shoes installed on the wheels to prevent overturning. These devices increased the support area and prevented the wheels from sinking into soft ground. 10 such shoes were required to be installed on each wheel. Their use was considered a necessary condition for moving the howitzer into position over difficult terrain. During the final trials of the gun, there were certain concerns about its operational qualities. However, the first shot demonstrated the system's effectiveness. Recoil, characteristic of guns of this caliber, was effectively compensated. The mount swayed slightly, then quickly returned to its original position. A subsequent shot confirmed the stated characteristics. The test reports documented: recoil action balanced, stability satisfactory. Thus, the first functionally mobile variant of a heavy howitzer produced in one of the countries was developed. Despite retaining significant dimensions and overall unwieldiness, the mount gained the ability to be moved without complete prior disassembly. Transportation was carried out by artillery tractors, with the barrel facing backward, taking into account the need to overcome road irregularities. To ensure maneuverability, the rear axle was made steerable. During long-distance transfers, the structure was partially dismantled by removing the barrel and part of the recoil cylinders. Gradually, new artillery systems began to enter service with the troops. It was noted that, despite the continuing complexity of transportation, the significantly reduced time for deploying the gun, from a day to several hours, substantially increased tactical flexibility. This allowed the command to plan battery maneuvers more effectively. By the end of 1917, a number of such systems had been used in combat conditions. They demonstrated the ability to function in challenging mountain terrain, mud, and snow. Personnel operating the guns highly rated their characteristics. Cases were recorded where opposing forces also noted the accuracy and power of these systems. Towards the end of the conflict, interest in the De Stefano project grew. Luigi Stampa, head of the Genoese Artillery Company, initiated the creation of an experimental battery based on this system with the aim of further reducing weight and accelerating deployment. The achieved results were assessed as positive, but mass production of these improvements was not started before the end of the war. In the post-war period, engineers had the opportunity to conduct a technical evaluation of the developed system. The perception of the Howitzer's unusual design changed. It was determined that the effectiveness of this design lay in its ability to provide characteristics comparable to the advanced artillery systems of that era. With the conclusion of major military operations on the European continent, thousands of artillery pieces were decommissioned. A significant portion of these systems was sent for melting down. However, a heavy Italian-made howitzer, developed through intensive engineering work, found continued use. Instead of being scrapped, these guns were integrated into defensive structures. After the end of the First World War, heavy artillery was reorganized. Combat units were disbanded and artillery batteries were dissolved, but the guns were retained. They were transferred to the coastal artillery system known as the Naval Militia. These batteries were fortified positions on the coastlines intended for defensive purposes. In the 1920s, the political situation in the Mediterranean region became more acute. The period of peace was regarded as temporary as states rearmed, built fortifications, and prepared for potential conflicts. Howitzers, previously used for destroying mountain fortifications, were reoriented towards naval targets. They were installed on concrete platforms in the areas of Naples, Taranto, and Sicily. In these locations, previously associated with natural sea sounds and civilian activities, batteries designed to fire upon naval targets were positioned. Engineers modified the carriage system, adapting it for stationary positions. The guns were oriented towards the horizon. Crews underwent extensive training to practice elevation angles and accuracy. The elevation and recoil mechanisms developed by De Stefano proved highly suitable for stationary fortifications. The shots produced possessed significant power, while the recoil did not cause destruction to the concrete foundations. Subsequently, it was determined that coastal artillery was not the sole application for these guns. In the mid-1930s, some of the howitzers were transferred to border services. In the northern regions of the country, a new defensive belt, the Vallo Alpino, comparable in purpose to the Maginot Line, was constructed. Within this complex, which included concrete structures, tunnels, and armored firing positions, these guns were integrated into the defensive system. The total number in service comprised 16 stationary and 28 mobile installations. Their deployment reflected the evolution of military technologies between the two world wars. Despite their period of operation, the howitzers retained their combat characteristics. Their firing range exceeded 10.5 miles, and their heavy shells created significant craters. Documents from that period indicate that, although the equipment was considered obsolete in terms of moral depreciation, its reliability remained high. Nevertheless, due to reductions and re-equipping of the armed forces, the number of such guns gradually decreased. By the late 1930s, their numbers had significantly diminished. Reports from the War Department in 1937 mentioned the cessation of production for the De Stefano carriage system. Old models were kept in warehouses as reserves. Their operation continued even during the period of active introduction of new artillery systems and armored vehicles. In 1937, during the Spanish Civil War, several Italian howitzers were supplied to General Franco's troops. 5 units were delivered across the Mediterranean Sea to the Iberian Peninsula. They were used in siege operations against fortifications in the areas of Teruel and Madrid. It is reported that the guns were rated as reliable by Spanish personnel. By the beginning of the Second World War in 1939, Italy possessed a limited number of such systems. There were 10 units of the 1916 and 1917 modifications available. 4 coastal artillery batteries, each including 4 guns, were deployed in the areas of La Spezia, Taranto, and Catania. Several other units were used by border guards to protect passes and approaches in the Alps. With the country's entry into the war, these howitzers were again put into service. They provided coastal defense in the areas of Naples and Sicily, participating in repelling naval attacks and amphibious operations. Despite their age, these guns proved reliable. Their barrels, operated through 2 wars, retained the ability to fire heavy shells. It is noted that newer installations did not always demonstrate similar resilience. During the campaign in France, they were used to shell fortifications in the southeast. Subsequently, as the front line shifted, some batteries were redeployed south to areas where Allied forces were approaching Italian shores. In Sicily, these guns performed their last combat missions. During the defense of Catania, they fired upon naval landings. By the end of the war, despite their proven reliability, most units were destroyed or put out of action. However, several specimens were preserved until the 1950s. They remained in old fortifications, subject to corrosion, yet retaining a potential readiness to fire. Archival reports indicate that individual units remained in service until 1959. Thus ended the operational period of this heavy gun, which began with critical evaluations and concluded with a long period of duty in coastal areas. The system, initially characterized as inefficient or cumbersome, remained in service for a significant historical period, encompassing 2 world wars and several changes in military doctrines. Antonio De Stefano's development ensured its continued use after 1916. The gun, designed in the early 20th century, remained in operation until its second half. Its design demonstrated a combination of power and engineering solutions. The attitude of maintenance personnel towards the gun in its final years of service was similar to that noted during the First World War. After the end of hostilities, Italy rebuilt its infrastructure. Guns previously used in combat conditions were now in a stationary state. Among them was the heavy howitzer, whose service life spanned half a century of history, 2 major military conflicts, and several stages of Army reform. In the post-war period, these guns were rarely mentioned. Reports from the military department indicated that individual samples of old coastal guns of 12 inches caliber were in service. These installations were positioned near Naples, Taranto, and the Strait of Messina and were subject to corrosion. The dismantling of such systems was economically unfeasible, and they also retained their functionality. The mechanisms developed by Antonio De Stefano demonstrated high reliability, allowing them to be brought into working order even decades later. The steel rails of the gun carriage retained their straightness, the recoil cylinders their hermetic seal, and, given the availability of ammunition, the guns could be brought into action. Their design was characterized by a combination of a massive external appearance with high internal strength and meticulous detailing. In the early 1950s, some of these large caliber guns continued to remain part of coastal defenses. Against the backdrop of new weaponry, jet aircraft, radar, and submarines, they were perceived as outdated equipment. In the military garrisons where these guns were operated, the principle of readiness for deployment was maintained. Annually, artillery crews conducted inspections, barrel cleaning, mechanism lubrication, and aiming drills. The high degree of reliability of these systems was noted, contributing to their long service life. Some military personnel from that period described these guns as possessing a unique character and high survivability. The number of such installations gradually decreased. Some were dismantled to make way for new systems, while others were left exposed to corrosion outdoors. Nevertheless, in some abandoned fortifications, they continued to remain in their positions. In Sicily, near Catania, one of the old concrete fortifications with the remaining installation was used for a long time as an ammunition depot. The official decommissioning of such installations was often delayed, which allowed them to effectively integrate into the surrounding landscape. The last official mentions of these guns date back to the late 1950s. Documents indicated that some installations continued to be listed as operational. In practice, they were no longer used for firing, but maintained their combat-ready status. The deployment of these systems was not planned, but they remained in position with their barrels aimed towards the sea. Their design embodied an engineering approach focused on strength and survivability in combat conditions. The service life of these guns exceeded 40 years, starting from the first recorded shot in 1915. During this period, political regimes and state symbols changed, yet the guns continued to hold their positions. Among artillerymen, there were opinions about each installation having a character, manifested in various firing characteristics such as recoil or smoke emission. This example of heavy weaponry, developed by Italian engineers, demonstrated high operational reliability. Its reputation spread even among those who had not had the opportunity to observe it directly. Probably for this reason, an attitude of respect towards it was maintained even decades after its decommissioning. Over time, the surrounding concrete became covered with cracks through which vegetation emerged. The paint lost its integrity and metal parts succumbed to corrosion. However, the object's original form remained unchanged. Its characteristic shape, a tall structure with a narrow base and a large-sized barrel, was a distinctive feature. Its appearance was perceived by some as unusual, yet it was also associated with power. Those who observed it might react with laughter, but those aware of the object's history perceived it not as a curious contraption, but as a reflection of the engineering principles of an era where functionality, not aesthetics, was the priority. One of these howitzer models remained operational at its position until 1959. The last shot was fired not during combat, but during training exercises. The sound of the shot spread over the sea, dissipating in the wind, after which silence returned to the position. This event marked the end of an era of heavy artillery systems, a period in which each unit of such weaponry represented a complex design, and each shot required the coordinated efforts of many specialists. Thus, the operational lifespan of this steel object came to an end. An object which, early in its existence, sometimes drew controversial evaluations, and which concluded its service as a veteran of military conflicts. Its active service life exceeded the lifespan of many of its creators. It was in service during periods of revolutions and peace agreements. ending its journey unnoticed, without public ceremonies, gradually fading into the past.